हेलो आवाज़ आ रही थी माइक से। हम एक्स्ट्रा वाले लाल वाले हैं क्या? मैंने तो सब बच्चों को चीफ गेस्ट को भेज देना रहेगा। ओ बाप।
A very good morning to one and all, and a warm welcome to the dignitaries, excellencies, honorable speakers, distinguished guests, honorable president, IPS Academy, principal IPS Academy, Institute of Engineering and Science, all the deans, head of the department, esteemed faculty members, dear participants and students. It fills our heart with immense pride and gratitude to have you all here today for this remarkable event of inaugural ceremony of IEEE International Conference on Computational Communication and Information Technology, which is organized by Computer Science and Engineering Department, IPS Academy, Institute of Engineering and Science, Indore. IPS Academy, Institute of Engineering and Science, is one such institution in central India that has grown from strength to strength in the past 25 years since its inception. An autonomous institute affiliated with RGPV Bhopal and approved by AICTE, IPS Academy offers 14 undergraduate and 8 postgraduate programs with accolades like NAC accreditation, NBA recognition, and ranking 6th in the West Zone under Times Engineering Survey 2024. It has become a hub of innovation, research, and holistic development. IES has also excelled in fostering student success through initiatives like Smart India Hackathon and international collaboration with institutes like University of California, Los Angeles, WPI, USA. We are more than an institution. It's a movement towards sustainability, societal development, and innovation. With initiatives like Unnat Bharat Abhiyan, industry collaboration, and state-of-art research in areas like microfluidics and seismic analysis, IES is shaping the leaders for tomorrow. And within the IES flourishes the Department of Computer Science and Engineering, which started its journey in 1999 with the first batch pass out in 2003. Department has a strong commitment to excellence in undergraduate, postgraduate, and research education. The curriculum redesigned post-autonomy is intensive and hands-on, with an emphasis on theory and practical, along with exposure to advanced specialization in data science, AI/ML, IoT, and cybersecurity for the students. To make the students industry ready, curriculum includes credit-based internship, technical training, spoken tutorial course, IIT Bombay, and project competition, UDAN, and many more.
Moving ahead with today's event of inaugurating IEEE conference, let us seek blessings from Goddess Saraswati. I request the guests and dignitaries, Honorable Chief Guest, Professor Nitesh Purohit Sir, Guest of Honor, Professor G.S. Tomar Sir, other Guest of Honor, Professor R.K. Pateria Sir, Principal Dr. Archana Kirti Chaudhary Ma'am, Head of Computer Science and Engineering Department, Dr. Neeraj Srivastav Sir, Dr. Alpana Rajan Ma'am, Dr. Manish Dikshit Sir, and Professor M.P.S. Chawla Sir to kindly come forward for lamp lighting.
श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा। शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदाम् जाड्यान्धकारापहाम्।
Thank you all. I request the guests and excellencies, Professor Nitesh Purohit sir, Professor G.S. Tomar sir, Professor R.K. Pateria sir, Dr. Archana Kirti Chaudhary ma'am, and Dr. Neeraj Srivastava sir to kindly come on the dais and take their seats. Growth is the result of forces working together. And undeniably, it is a proud movement for IPS Academy, Institute of Engineering and Science, that we have been honored by the presence of such great and renowned personalities gathered here, which support IEEE MP section, IEEE Computer Science MP section, our management, and under the guidance of our respected principal, head of department, senior professors, mentors, and enthusiastic faculty members, the Department of Computer Science and Engineering is conducting this priceless event. It is indeed a golden opportunity for each one of us to enrich and enlighten ourselves. The fields of computational intelligence and information technology have grown tremendously over past few years, and the credit goes to the evolving soft computing, artificial intelligence methodologies, machine learning, robotics technology, self-driven vehicles, new medical devices, Internet of Things, Industry 5.0, tools and techniques for envisaging the essence of intelligence embedded in real-life observations. As traditional models struggle to cope with complexity, noise, and the existence of a changing environment, while computational intelligence and information technology offer solutions to complicated problems as well as reverse problems. And to address such buzzing advanced technical areas, we have a panel of expertise with us. Let's proceed with welcoming our distinguished guests. I request Principal, Institute of Engineering and Science, Dr. Archana Kirti Chaudhary ma'am, to welcome our chief guest of the event, Professor Nitesh Purohit sir, Director, SJSITS, Indore, with a sapling. Thank you, ma'am. Again, I request Principal ma'am to welcome Professor G.S. Tomar sir, Chairman, IEEE MP section. Thank you, ma'am. I request Head of Computer Science and Engineering Department, Dr. Neeraj Srivastava sir, to welcome Professor R.K. Pateria sir from Manet, Bhopal. Thank you, sir. I request Professor Arvind Upadhyay sir to welcome Dr. Alpana Rajan ma'am, Head Advanced Applications and Scientific Computing Section, RR CAT Indore. Thank you, sir. I request Professor Sunil Nimawat, sir, to welcome Professor Manish Dikshit, sir, Vice Chair, IEEE MP Section. I request Professor Yagyapal Yadav, sir, to welcome Professor MPS Chawla, sir, Treasurer, IEEE MP Section. Thank you, sir. Now I request Dr. Neeraj Srivastav, sir, Head, Computer Science and Engineering Department, IPS Academy, Institute of Engineering and Science, and convener of this conference, to welcome our guests in this event and also give brief information about the conference.
Thank you, ma'am. Good morning to all. It is our pleasure to welcome our chief guest, Professor Nitesh Purohit sir, Director ICCCIT Indore, respected Presidents, Architect Achal K. Chaudhary sir, guest of honor, respected G.S. Tomar sir, Chairperson IEEE MP Section and Director GEC Sonbadh. Guest of honor, respected Professor R.K. Pataiya sir, Professor MNIT Bhopal. Keynote speaker and esteemed guest, respected Director Arpana Rajan ma'am, Associate Director, TDSG Group, IRCAT Indore. Esteemed guest, respected Professor Manish Dikshit sir, Vice Chair, IEEE MP Section, and Professor MITS Gwalior sir. Esteemed guest, respected Professor MPS Chawla sir, Professor SGS ITS Indore, and Treasurer IEEE MP Section. Esteemed guest, respected Professor Sayan Singh sir, Vice Chair, Outreach, IEEE India Council. Respected keynote speaker who are online present, respected session chairs come across various institutes, our visionary principal, Dr. Ashna Kirti Chaudhary ma'am, our participants, deans, HODs, faculty members, and my dear students. To IEEE International Conference on Computational Communication and Information Technology, ICCCIT 2025, hosted by Department of Computer Science and Engineering, IPS Academy Institute of Engineering and Science, and sponsored by IEEE Madhya Pradesh Section and IEEE Computer Science MP Section. This is a momentous occasion that brings brilliant minds across the world. I am delighted to present brief of the conference, which promises to be outstanding forum and exchange knowledge, value, and collaboration. Paper submission was carried out through Conference Management Toolkit CMT. We received overwhelming response from around 800 plus manuscripts from all over the world, such as USA, UK, Bangladesh, China, Saudi Arabia, Sri Lanka, Pakistan, and many more countries, including around all the states of the India. The selection of the quality of manuscript was a rigorous process which involved detailed evaluation by experts in the field. Only 160 manuscripts were accepted for presentation in this conference. This process was highly competitive and ensuring the quality of the most original, impactful, and technical sound paper are included. We have keynote speaker with us, Dr. Arpana Rajan, Associate Director, TDSG Group, Head Computer Division, IRCAT Indore, who will deliver high-performance computing. Dr. R.K. Pataiya sir, Professor MNIT Bhopal, who will deliver on cybersecurity. Mr. Narendra Chintamau, founder and CEO, Maha AI, USA, who will deliver bringing ancient wisdom by connecting with the advanced modern technology. Dr. Vikram Badoya sir, Professor, Texas A&M University, Texas, USA, who will deliver on future technology will be BAD. Dr. Naika Upane, Ratube University, Australia, who will deliver IoT meet AI. Senior researchers Umar Mohammad Mudibo from Mudibo University, Nigeria, who will deliver on cloud computing environment. Dr. Praveen RVS, Director Product Engineering, USA, who will deliver challenging and implementing AI. In these 2 days, we have total 16 sessions, 8 sessions each day in parallel in hybrid mode. Finally, I encouraging all the participants to attend maximum keynote speakers and expert talk and session and keep participating and do not hesitate to ask questions. The success of the conference is not only presented the quality paper, but also lies in creating collaboration and connection for future endeavors. We hope you find this conference interactive, stimulating, and professionally rewarding. Together, let us continue to push the boundary of knowledge and technology for a better future. Thank you.
Thank you, sir. An enigmatic personality with a zeal to make impossible possible. Principal, Institute of Engineering and Science, Dr. Archana Kirti Chaudhary ma'am, who has always been a source of motivation to one and all of us to move ahead. I request her to kindly come and welcome our guests.
Thank you. A very good morning to one and all. Good morning. On behalf of IPS family, first of all, I would like to welcome our chief guest, Professor Dr. Nitesh Purohit sir. This is your first visit to IPS Academy. Thank you, sir, for accepting our request. Purohit sir is the director SGSITS Indore, the prestigious college. Dr. Tomar, GS Tomarji, Chairperson IEEE MP Section and Director Government Engineering College Sonbhadra as a guest of honor. I welcome my batchmate, Dr. R.K. Pateria sir, Professor Manit Bhopal as a guest of honor. Our esteemed guest, thank you, Dr. Alpana Rajan ma'am, Associate Director, Head Computer Division, RR Catch Indore. Our esteemed guest, Dr. Manish Dikshit ji, Vice Chair and Chair Professional Activities, IEEE MP Section. And Professor Amaitis Gwaliar, welcome to IPS Academy, sir. Our old colleague, our guide, our teacher, our esteemed guest, Dr. MPS Chawla, sir. He's the Treasurer, IEEE MP Section and Professor, SGSITS Indore. If I am not wrong, he is one of my mentor. So he contributed a lot for the development of IPS Academy. Another esteemed guest, Dr. Shailendra Singh ji, Vice Chair, Outreach, IEEE India Council. Welcome to IPS Academy. Our Dean of Academics, Dean Student Welfare, Dean Research Development, and all head of the departments, faculty members, and I think above all, my dear students, humble request, actually you are the beautiful flowers of this garden. Kindly spread fragrance in this garden with your broad smile. IPS Academy is one of the leading self-financing group of institutions. It's a UGC autonomous institute since 2020 and devoted to impart quality education with the sole motto of knowledge, skill, and values since 1994. However, the engineering college was established in 1999, and in the last year, we completed the 25 glorious years, successful glorious years. We are offering multiple programs of every color, that is engineering, architecture, management, pharmacy, that is technology, management, science, along with the performing arts, fine arts, which ultimately helps in holistic development of the student along with their professional and academic development. Based on the performance of the academy, we are able to receive accolades in every sphere of education. It may be fine arts, performing arts, or it may be technology or management or architecture. So architecture helps us in creating the better society, and engineers are called as the creators of the society. Today, as an addition to academics, we got the opportunity to organize IEEE conference. It's my great pleasure, again, to welcome you all to this IEEE International Conference on Computational Communication and Information Technology. This is organized by Department of Computer Science Engineering of our institute. I hope this conference serves as a premier platform for the exchange of knowledge, for the exchange of thoughts, informal or formal interactions, fostering collaboration not only with the academics but within the institutes, industry and research communities to address the emerging challenges and the solutions as well as the advancements in computational and ultimately the communication technologies. In this era where digital transformation is redefining our industries, computational intelligence, and information technology, which plays a pivotal role in shaping a smarter and more connected world. This conference brings together the leaders, researchers, practitioners, students, faculties to deliberate on cutting-edge innovations. I usually said this is not the delivery session, it should be an interactive session. So the cutting-edge innovations in artificial intelligence, cybersecurity, IoT, big data analysis, and next-generation communication system. With the help of interaction, you are having the opportunity. So I think you should grab the opportunity to interact with the most prestigious persons who are delivering the session today, or who are available here for interaction with you. I extend my sincere gratitude to all the IEEE members, to especially the IEEE keynote speakers, session chairs, and all contributors who directly or indirectly help us in organizing this conference for their invaluable support in making this event a success or in making this event to happen. I am confident that the discussions and insights shared over these 2 days will not only inspire new ideas, but ignite you also for the collaborations and pave the way for future technological breakthroughs. Wish you all enjoy 2 days, wishing you all the enriching and the productive conference. Thank you very much.
Thank you, ma'am, for your unwavered guidance as always. We have with us guest of honor, Professor R.K. Pateria, sir, who is currently giving his valuable services to Manit Bhopal as Chairman, Central Computing Facility and Professor in CSE Department. Professor Pateria is also Principal Investigator of ISEEE project, Government of India. Sir has supervised more than 14 PhD scholars and guided more than 350 BTech and MTech students. There are more than 150 research papers under his name in reputed journals and conferences. He has a strong research background with more than 70 publications in the fields like machine learning, optimization technique, computer and network security, e-commerce, e-governance, and randomized algorithms. He has also patented his work, a system of intelligent attachment to control wheelchair by motion based on human gesture in 2021. Sir has authored a book and contributed several book chapters. He has delivered many keynote speech and invited talk in international, national conferences and workshops. He has visited many countries including Australia, China, Singapore, Hong Kong for academic collaborations. His research interests include machine learning, cloud computing, and cybersecurity. We are fortunate to have such an eminent and scholarly personality.
System, it is a highly suboptimal way. And then he said that what is required to be done. And a paper was published. And in the electronics communication engineering, computer science, information technology, BTech courses, there is a part, or there is a complete paper, complete subject running on the findings of that particular person. And the title of the theory is information theory. नाम सुना है किसी ने information theory? That's really good. And information technology is something eventually emerged out of that theory, information theory. And I should tell you that all the communication systems that we are using today, including internet or 3G, 4G, 5G, whatever comes in your mind, all these communication systems are primarily governed by the Shannon's framework, the same 1948 theory. And in fact, there is no communication system today which is not following that framework except FM radio, which is indeed an analog system. So in the 1948, all this started. And as I said that even today, all the communication systems are following Shannon framework. One of the paper which went unnoticed for a long, long time, written by Shannon as a second author, and the first author was Weaver. And there he defined that actually the communication system working principles should be divided into 3 levels. And whatever was proposed in 1948 paper, this is just level A of the entire communication problem. And he named it that this is something which is a technical problem of communication. Okay. And 2 more levels were defined there, level B and level C. And Shannon said that level B is something related with the semantic problem. So what was level A? Level is something which we are calling technical problem. It concerns only with the faithful transmission of the symbols. So once the symbols or the message is faithfully transmitted, then it is the semantic level that what is the understanding after receiving those correct symbols at the destination. The understanding is semantically how much accurate. So this is something which was missing earlier. And the third part is also included, which is the level C problem. And the level C problem was the effectiveness problem, okay, defined in 1954 itself. That after receiving the message at the destination, the action taken was as per the desire of the sender or not. So that is also something which is required to be assessed. So the interesting question is, if all this was defined in 1954, why did not we took cognizance of all these things earlier? And the answer is, first thing, it was not needed. Basically, first of all, it is the need, isn't it? It is the need. Just like in the 1948, Shannon postulated the theory, but not beyond 1975-80, it was actually started implementation of this thing. Because when need arises, then only people switch the technology. So now the need has arisen that we need to go beyond level A, and we need to consider level B and level C problem as well. And fortunately, very fortunately, I should say, the technology is now available. The technology is now available, and the technology is the buzzword of today, artificial intelligence. Naam suna hai? So, artificial intelligence is something we need to understand first of all. Okay. we need to understand that what is going on in the world. Then only we can capture actually what is going on and what is supposed to be done by us. Okay. So I'll give you a glimpse actually. In 2015, probably most of you already know it. I'm just putting the chronology, just wrote it here. So in 2015, actually, OpenAI was established. Okay. नाम सुना OpenAI का? OpenAI was established in the United States of America, and it was established as a non-profit organization. And research started. Then interestingly, in 2019, it was announced that OpenAI is now no more a non-profit organization, but now it is a kept profit organization. Okay. In 2019, it happened. Okay. Then in 2022, OpenAI released ChatGPT. And then actually, if you just see what happened as a follow-back action in the world, you will see that the government of India announced India AI mission, and government of India sent 10,000 crore dollars will you put into this particular thing. In 2023, DeepSeek was established in China, and only a few days back actually they have announced something. And just see actually the point which I want to make is, you need to understand the trajectory on the world is moving, and you need to see where we are. What are we doing? Okay. So my dear friends, if we do not take the right kind of action at this juncture, then we will fall behind. And everyone at the top level at least, this clarity is achieved. Now we need to take it to the right persons who are going to do it. Because what is interesting in the DeepSeek as compared to OpenAI, DeepSeek is something developed by a young person, and the entire contribution is from the young persons only. And you can search the Google and find out precisely this is something. Actually, only 2 days back, there is a professor at IIT Kanpur, Nishit Srivastava, who is mentor to a Section 8 company, Airavat Foundation. A very good comparison was published. Actually, what I am saying, precisely most of the contribution is coming from that particular article only. Precisely, it was narrated that what is OpenAI doing. I should also tell you, probably you may be known, $500 billion in the next 4 years, US government is going to spend on this thing. The OpenAI and a consortium of 2-3 companies. So that's an important aspect that all of we need to understand. And probably this is the conference, the theme of the conference is something which is perfectly matching for triggering this kind of discussion. You have very eminent keynote speakers in the conference. You must be having good quality papers, it was informed. So I request all of you, so please attend all the conferences, all these sessions in the conferences, trigger the discussions, and come up with the good solutions, which should take our country forward. We are not able to invest so much, $500 billion in 400. It's impossible for us. So we are a country actually where in the minimum amount of money we need to deliver. So it is possible only if, in fact, if you just see this LLM thing which is going on behind all these things. Okay. So, reinforcement learning from human feedback. Great thing is going on. Just have a look at it. In fact, this is something because of which DeepSeek is much and much cheaper as compared to the this ChatGPT. So things are going on, a lot of things are going on. The world is changing very, very fast, faster than whatever we are imaging over here. Let us catch with it. Thank you very much. Namaste.
Thank you, sir. A conference inaugural ceremony is incomplete without its proceeding. I request the dignitaries on the dais to kindly unveil the proceeding booklet and officially declare the opening of this conference. Thank you all. Gratitude is the fairest blossom which springs from the soul. For the felicitation ceremony, I request Principal Dr. Archana Kirti Chaudhary ma'am to kindly present a token of gratitude to Professor Nitesh Purohit sir. Thank you, ma'am. Again, it would be very kind of ma'am to facilitate Professor G.S. Tomar, sir. I request Dr. Neeraj Srivastav, sir, to felicitate Professor R.K. Pateria, sir. Thank you, sir. I request Dr. Vaishali Gupta, ma'am, to felicitate Dr. Alpana Rajan, ma'am. Thank you, ma'am. Now I request Professor Ved Kumar Gupta sir to honor Professor Manish Dikshit sir with a memento. Thank you, sir. I request Dr. Indra Kumar Shah sir to present memento to Professor M.P.S. Chawla sir. I request Dr. Pratik Nahar sir to felicitate Professor Shailendra Singh sir. Thank you, sir. Moving towards the culmination of this inaugural ceremony of IEEE conference, I request Professor Arvind Upadhyay sir to please put vote of thanks.
Respected dignitaries on the dais, distinguished guests, esteemed keynote speakers, session chairs, most valuable participants, various deans, head of the department, and dear students. As we are going to conclude the inaugural session of this first IEEE International Conference, I am honored to extend my heartfelt gratitude to all who have made this conference possible. I extend my sincere thanks to Dr. Ritesh Purohit sir, Director GSITS Indore, guest of honor Dr. G.S. Tomar sir, Chair IEEE MP section, guest of honor Dr. R.K. Pateria sir, Professor Manit Bhopal, our esteemed guest Dr. Alpana Rajan madam, Associate Director TDSG Group and Head Computer Division Raja Ramanna CAT Indore, Dr. Manish Dikshit sir, Vice Chair IEEE MP section, Dr. MPS Chawla sir, Treasurer IEEE MP section, Dr. Sailen Singh sir, Vice Chair Outreach IEEE India Council, for spending their valuable time with us to grace the occasion. Your inspiring words and valuable insight have truly set the tone for the conference ahead. I extend my sincere thanks to our sponsor, IEEE MP section, IEEE MPCS sections, for providing us the opportunity to organize this conference. Without their support, this would not have been possible. I extend my sincere thanks to management of the IPS Academy, our dynamic principal, Dr. Archana Kirti Chaudhary madam, for constant support and providing all the stuffs for execution of this conference. Lastly, I want to thank all the members present here for as being part of the ICCCIT 2025. Let us together we contribute in the field of research and emerge a fruitful results from this conference. Thank you.
Thank you, sir. I request all to kindly raise and stand up in attention for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Kindly take your seats, please. For rekindling memories, may I request panel of dignitaries to gather for a group photograph. May I request all the participants to kindly stand up at their places for a group photograph with the dignitaries, please. Please stand up at your places. उनके ऑफिस पहुंचाना है, ऑफिस पहुंचाना है। किसी को दे दो, तुम मत जाओ। It is requested to all the participants, faculty members, and students of Computer Science Department to stay back in the auditorium for the keynote sessions and the expert talks. Kindly remain at your seats, please. All students and faculty members are requested to kindly take their seats. Attention, please. Now we are starting with the keynotes of day 1. Coming together is the beginning, keeping together is progress, and working together is success. With this motive of gaining and sharing knowledge and expertise in our respective fields, let's embark on this journey together with the experts arrived here. Today we have our esteemed guest, Dr. Alpana Rajan ma'am, Head Advanced Applications and Scientific Computing Section, RRCAT Indore.
Dr. Rajan has received her PhD in computer science from Devi Ahilya Vishwavidyalaya, Indore, India in year 2014. She has joined Department of Atomic Energy in 1989. Presently, she is working as an outstanding scientist and associate director of technology development and support group at RRCAT, which is R&D unit of DAE. She leads computer division at RRCAT, and her research interests include high-performance computing and high-bandwidth interconnect and network security. She has played pivotal role in establishing centralized computing facility for R&D project at RRCAT. She has planned, designed, and deployed high-performance computing clusters providing 240 teraflops of sustained computing power to the scientists and engineers of RRCAT. She is currently leading a team of 57 engineers and software professionals. She has more than 110 publications in journals and peer-reviewed the conferences. She received Devi Ahilyabai Holkar Nari Gaurav Alankaran Award in 2014 for her outstanding contributions in the field of science and technology, and also DAE Excellence Science, Engineering and Technology Group Achievement Award. I humbly request Madam to share her knowledgeful insights related to the topic's latest trends in high-performance computing.
Good morning, everyone. Good to see a large number of academicians, students, and researchers in this hall. And first of all, I would like to thank the organizers to give me an opportunity to deliver my keynote speech on trends in high-performance computing. And this is my field of specialization, and I have been working in this field for past 34 years in Department of Atomic Energy. One second. Next. Yeah. To bring the audience on the same platform, first of all, I will give a brief introduction of the topic so that everyone knows what is the high-performance computing. Although every one of us is a user of this, but architect of this technology, you have to be, as computer science engineer, you have to become architect of the technology, not mere user of this. So what is the technology behind so that everyone is at par? Then evaluation. Sorry to interrupt. If you are comfortable with this. Scholar, just check. Caller mic. then we will, am I audible? Am I audible? Yeah. So beyond after introduction, I'll tell you about the Moore's law, which is the basic behind the superconducting technology which we see today, and the evolution of supercomputers, and then high performance computing clusters which are available at Department of Atomic Energy, which we will be then, I will give you a brief about the cluster computing also, because you might have read in your notebook, textbooks, but to give you a feel of practical exposure, certain basic things I'll be briefly telling you. And then what are the HPC applications at DAE? What are the HPC applications in general in our country? And then the latest trends, exascale computing, quantum computing, a bit of it, then neuromorphic computing, analog computing, and things like that. And at the end, some concluding remarks. As we all know that computing is very essential requirement for computational intensive applications. And the field could be in the physics, chemistry, mathematics, even computer science, but the applied computing is used in our day-to-day life, as the previous speakers have told that even in day-to-day life you have a very powerful computer in your pocket, that is a smartphone. The technology remains the same at the back end, and then it is done basically, if you see high performance computing, it is used for simulation, modeling, forecasting, and predictive analysis of the huge amount of data which is generated every day. Conventionally, computing was carried out on a very large scale machines, like it used to take something about more than this big hall to house the machine, lot of power requirements. Still, power requirements are still there. The cooling requirements are there to cool down the machine, but now miniaturization and the software trends have led to AI/ML technologies. So you have a computing machine in your pocket which is using ARM processor. And broadly speaking, computing can be divided broadly in two parts. Sequential computing, you all know that. You put the input, you get the output on one single machine that could be having multiple cores, multiple processors, but the task is utilizing multiple cores within the same program. And the data set is not divided. Whereas in cluster computing or parallel computing, the task is divided into multiple subtasks, and the result is combined and put it to the user. So this is what happens is program is running on multiple processors or multiple cores. What is the driving force behind all this is complexity of the problem which is to be solved on the computer, which has governed to the evolution to this extent that now we have exascale computers already available in top 500 list. Yeah, the foundation of the computing in this modern era is Moore's law. Gordon Moore, who proposed this law in 1965. He was the co-founder of Intel and Fairchild Semiconductors, and then later he was CEO of Intel. So what he said was, the number of transistors on integrated circuit double every 2 years. And this is actually not a physics law. It is a prediction based on the historical data. So based on that, semiconductor industry is planning their future R&D projects, aligning their subsequent plans to come out with latest chips. And this has been the guiding force behind that. And it has provided exponential growth in terms of computational power, efficiency, and when the ICs are produced on a mass scale, it becomes more affordable because of the cost reductions. The impact is seen in our daily life. Faster processors, which are driving forces behind simulation, behind computations, and AI, and new era of gaming. And its widespread adoption has resulted into computing becoming more affordable. That's why I said that every one of us has got a smartphone in the pocket. Earlier, as Dr. Pahadia said that when the man landed on moon, the computational power used was equal to what you have in your pocket today. And then energy efficiency. Smaller transistors lead to less power consumption, enabling the portable devices. And new era has opened, new scenario has opened for HPC, high performance computing, AI, cloud computing, and gaming, which have been benefited from the scaling. If we see, sorry, this pointer will not work. If we see that 42 years of microprocessor trend data, if you see the number of transistors in terms of thousands of transistors, it has go on increasing over a period of years. And single thread performance, that is performance of processor, is measured by spec int, spec FP. These are the performance calculations for a processor. So it has got, you see, it is going on increasing. The frequency of processor up to 2015-16 was going on increasing. But there was a point, because what happened was the power dissipation by the processor became too large to handle, and because you need to have the cooling arrangements for the processor. So it was felt that there should be smaller units known as processing cores, which will have ALUs and registers only, not a general purpose machine. So with ALUs and registers, you can go on increasing the number of processing cores and some reduced performance. The benefit was that, there is a white paper by Intel on this, the benefit was that the processing power was not compromised to a large extent. So you increase the number of cores and you get the sort of equivalent computing power with that increase in number of cores instead of increasing the gigahertz of the processor. So that's why the processor gigahertz is not increasing linearly after 2016, whereas number of cores in a processor are increasing. Currently 32 core, 64 core processors are available in the market. Typical power consumption when the concept of cores was introduced by semiconductor giants like IBM, like Intel. So power consumption came to steady state and sometimes at a lower rate. And number of logical cores which are available has gone on increasing. And this Moore's law has affected the evaluation of the computing. It has given the future, it has shaped the future of computing. But currently, if you see, the transistors are nearing the atomic scales, that is put a physical barrier, and difficult to manage the power densities, okay? And rising costs of manufacturing smaller nodes, because nanometer technologies are used for fabrication of processors, the costs are increasing, and scaling cores no longer is solving the complex problems. Because of proliferation of AI/ML based systems, you need to have certain other paradigms in computing. So that has given to rise of specialized hardware like GPUs, graphical processing units. They are nothing but processors only. They can divide the task into millions of smaller jobs and work on that all at once. GPUs are used extensively for AI-based computation for training of the model at the back end. And then TPUs, tensor processing units. This is developed by Google, not available for processing, buying, procurement. You can buy the compute on Google Cloud, but not the TPUs, and build your machine. FPGAs for efficiencies, and ASICs, application-specific ICs like NLU, LPU, they have been developed by various semiconductor giants, which are helping the applications, training the model for the AI systems. Here, it has given rise to heterogeneous computing. combining the power of CPU, GPU, FPGAs, ASICs for efficiency. And actually, there is a concept of near memory computing. You might be knowing it. NMC chips are launched where you carry the computational logic near to the source of data. So expensive data movements are stopped, and this has helped in resolving the memory wall issue. Memory wall issue was coined in 1994 because the computational power was being restricted by the memory bandwidth, the memory transfers, data transfer between memory to processor. So this near memory concept was evolved initially in the at the software level, and finally now chips are available. Edge computing, it is bringing computations and data storage both near to the source of data. Like if you remember content delivery networks for delivering the videos on demand to you, so that is from a server, a cluster available nearer to you, geographically nearer to you. And this has been now used widely by e-commerce companies for preparation of e-cards and presentation of websites geographically nearer to the user. So in fact, Google also has got so many data centers across the world. So many clusters are deployed by them across the globe to provide you the source, the computation power near to the source of the data. And now beyond silicon, quantum computing, neuromorphic computing for a paradigm shift. So I'll be briefly touching in subsequent slides upon these points also. How many of you know about the top 500 list, that top 500 project, a global project? Probably none of you, sorry. So this top 500 is a project which lists the top 500 machines at international level twice a year, once in June, and another list comes out in November every year. This lists the top 500 supercomputers. Supercomputers in the sense they are non-distributed computers, non-distributed, okay? So these systems have utilized GPUs. The top 10 machines in top 500 have utilized GPUs and other accelerators like TPUs and other machines, demonstrating the dominance of heterogeneous architecture in supercomputing phenomena. And ARM architecture also has played a very important role. Fugaku supercomputer of Japan, it topped the list in 2020, which is based on a ARM architecture. So even ARM architecture based machines are having a dominant role in HPC arena. And then interconnect. Interconnect plays a very vital role because there are so many nodes, they have to be connected to each other for communication at a very high speed. So something similar to 200 Gbps, 400 Gbps, currently in labs, 800 Gbps InfiniBand interconnects are being tested, and for very fast communication between the two processors. So this is playing a very important role. And for energy efficiency, there is a Green 100 list also, which is it highlights the energy efficiency of the machines, and the most efficient system achieved performance per watt in the range of 60 plus gigaflops per watt. That is quite more than your, do you know how much is the processing power of your individual laptops? How do you calculate the performance of a machine? How do you calculate it? It is very simple formula, mathematical formula for calculating the theoretical performance of any machine. The clock frequency of the processor into number of processing cores and into floating point operations per second of that code name of processor. Because these semiconductor manufacturers like Intel, or AMD, they give that Skylake processor will have 16 flops per second or 8 flops. So that you have to take from the data sheet, and then you come to calculate about the, you can calculate the theoretical computing power of the machine. And this list is actually topped by majority of the systems are from US and China, and few of them are from Japan. I'll tell you about the situation of Indian supercomputers also. Currently, earlier Intel was dominating the scenario of HPC. Now AMD has come into the picture. And the first exascale machine which came in 2022 list was based on AMD processor, its own GPU, its own CPU. And then because now NVIDIA, AMD, Intel, they all are in market for GPUs. Intel is not in GPUs. So there is a fierce market competition. So as a user, we are benefited. And Frontier, which was Frontier machine, first exascale machine, was powered by AMD GPUs and CPUs. And current machines, but I'll tell you one thing. This is whatever is published on as white papers on the, you can Google it. But the internal architecture of the InfiniBand, they don't publish because they are proprietary. So you don't get to know about the internal architecture of the InfiniBand interconnect, internal architecture of their proprietary processors in the top supercomputing list. These are the, actually Indian Institute of Science, Bangalore, publishes a list of top 10 machines in, top 100 you can say machines in India every year. And these are the top machines in India dedicated to the nation by Prime Minister, Airavat, developed by CDAC Pune, Arka, and Arunika, Pratyush, and Arka AIML. These are the top 500 machines. You can see two parameters, Rmax and Rpeak for all these machines. And Rpeak is what I told you for calculating the theoretical performance of the machine. Rmax comes after benchmarking the system. There is a high performance LinPack benchmark for non-distributed systems, and even top 500 supercomputers also use the benchmark. In fact, we also benchmark our systems using the same benchmarking routines. And then let us say hundreds of rounds of calculations on nonlinear partial differential equations are performed to come out to the what is going to be the performance of the system. So this Rmax shows that benchmarking, and this is known as sustained computing power of the computer. And this is actually will be available throughout its lifetime. Sometimes it is limited by if the cooling is less in the data center or power is not appropriate. So the sustained computing power may go slightly down. Little bit of cluster computing. These are basically multiprocessor machines working to solve a complex problem. It has got parallel components. They are processors having individual memories, and then high-speed interconnects to connect all the processors. And to the user, it appears as a single system. That is the main importance of a cluster machine, and even these supercomputers also are based on the cluster computing technology. And if I say the types of clusters, high availability clusters are used for critical applications like banking, e-commerce sites, reservation systems. High throughput clusters are extensively used for highly used websites, search engines, web-based email systems. High performance computing clusters are used for compute intensive scientific and engineering applications. So you see the applications are enormous, and as a user we all use those we are the front end users, but at the back end these are the machines which are powering the computations. Hardware components are there, interconnect, storage, management server, software components are there. You need to have the operating system, resource manager, monitoring tools, compilers, libraries for parallelization, user management tool, backup recovery tools. All these hardware and software tool put together will make your cluster working. Some of the clusters at Department of Atomic Energy where I have been working for past 34 years are, and I'll tell you these are the published details about the clusters. You all know the sensitivity of the department. So these are publicly available clusters, like announced in public. Much bigger machines are also available, which are not announced in the public. This Anupam Atulya has got 14,720 cores, 368 compute nodes with V100 GPU accelerator, 128 number of GPUs, and 141 TB of main memory. And it has got a peak computing power of 2 petaflops and sustained computing power of 1.35 petaflops. And it provides a comprehensive software environment using compilers of variety of compilers, because the scientific applications, the accuracy is very important when you run the simulations or computations. So they have to be compiler specific, whether it is a Intel compiler or GNU or PGI compiler like that. And wide range of scientific applications are available. At Raja Ramanna Center for Advanced Technology, which is situated right away 2-3 kilometers from here, my team has built a cluster which is, it integrates Intel Xeon Skylake processors, 64 compute nodes. It has each compute node has got 2 processors, and each one has got total around, this cluster has got 2048 CPU cores, and it has got NVIDIA Tesla P100 GPU accelerator card. So we have got around 57,344 GPU cores in the machine, and it has provided a sustained computing power of 190 teraflops. That is, the theoretical power was 250 teraflops. The sustained computing power after benchmarking came out to be 190 teraflops. And this is it is housed in a data center. We have got 2 data centers at RRCAT, state-of-the-art data centers, and the biggest in Central Asia, and the machines are also biggest in Central Asia, India, sorry. And this machine is used extensively by the scientists and engineers at RRCAT, and now we are planning for much bigger machines. Just a glimpse of the kind of applications which are being used in DAE per se or RRCAT. Computational chemistry, material science, I am not going to go through the list because it will take a lot of time. These are the applications, commercially available applications as well as custom developed software systems are being used on these clustering platforms. We have got around 5 machines, cluster computing machines, on which these codes are being run. For molecular dynamics, biophysics, for nuclear reactor physics, these are the codes which are being used. For plasma physics, for accelerator physics, engineering multiphysics, these are the codes which are available with us. And if you see the general HPC applications in India, the Ministry of Earth Sciences uses HPC for operational weather forecasting. I had told you the big list of top 10 machines in India, top 5 machines I listed. So some of them are used for these kind of forecasting. IITM and NCM are WFR key institutes using HPC for climate research. And high resolution monsoon models, they require significant computational resources, because there are going to be number of iterations, and to converge to the solution, it requires lot of computational power, so they use HPCs. And even HPC is used for real-time flood forecasting in some regions in our country. And Government of India has established a National Scientific Computing Mission also to put various stakeholders under one umbrella to work for the development of future machines for our country. And in aerospace and defense, organizations like DRDO and ISRO use HPC for aerospace simulations, and for missile trajectory simulation and modeling the flight paths of missiles and rockets. Actually, I would like to let you know the complexity of the HPC, because we know we give some program we run on the laptop. We get the output within, let us say, at the most few minutes. Whereas for scientific computations or such simulation and modeling, the code is being run for days together on such a powerful machine. In fact, even in RRCAT, where I belong to, the computations are running for months together on such powerful machines to converge to the solution. Then only the result is presented to the user or published in can be published in the international journals. So even such powerful machines, they require lot of time for coming to the solution. For cryptography and cybersecurity, also such machines are being used. In fact, for computational chemistry, material science, drug discovery, lot of computational resources are required. So all these are backed by the high performance computing machines. Is investing heavily in AI research and development, which relies on HPC. For financial modeling, for risk management and investment strategies, they rely on computations being carried on HPCs. Genomics, bioinformatics also use these kind of computational machines. Even for urban planning and simulating urban growth, traffic flows, resource management across the smart cities, such computational powers are required. For analyzing financial markets, assessing risks, and predicting market trends, such powers are required. Computational powers of this tune are required. Why such paradigms? And why new paradigms? It is a human tendency that, suppose you are devising a game to rotate a, let us say, cuboid in 2D or 3D, one cuboid. As soon as you finish that program, you will have this, why not two cuboids? Their interaction patterns. So human tendency to increase the complexity of the problem to be increased when you have the resources. This is a human nature. Once a problem is solved, you think of something else. You think of bigger problem. You think of complex problem. So complexity of the problem is increased, and subsequently the data size to be handled also increases. And time required to solve the complex problem is reducing. You want in fraction of seconds the result to be presented to you. So these are the factors which govern the expectations of users have increased, and these factors govern the rise of new paradigms. Users could be scientists, engineers, or even common people. In fact, even in our smartphone, if something takes some time, we think, kya hai, kyun nahi aa raha hai isme se? Itna time kyun lag raha hai? So that is a human tendency. So that is why new and new paradigms are evolving, and now we see what has happened currently is exascale computing. Exascale computing is systems capable of greater than or equal to 1 exaflop. That is 10 raised to power 18 IEEE 754 double precision operations. That could be multiplications or additions per second. And they are driving breakthroughs in AI, climate modeling, drug discovery, material science, and things like that. Current exascale systems are, in 2022, first exascale machine was launched. It was USA in that top 500 list. And the November 2014 top 500 list announced this EI Capitan. This is 1.742 exaflops. You see the computing power of this machine, sustained computing power. And it has got theoretical computational power of 2.746 exaflops. And this was officially dedicated on recently, 9th January 2025 only. But you see, as I told you, making such systems require a lot of resources in terms of data centers, in terms of power, in terms of cooling requirements. So this exascale machines, the energy consumption for such machines is to the tune of 20 to 30 megawatt per system, which is equivalent to powering 15,000 homes in developed countries. And in our country, it can power more number of homes. So, and the one is capital cost, another is operational cost. These systems, operational cost is also very, very huge. This is $600 billion machine. And now there is an effort for a sustainable exascale computing to use accelerators, AI accelerators, to reduce the power consumption, at reduced power consumption, provide more computing power. And the data centers could be based on solar, wind, or hydropower. And you need to have the liquid and immersion cooling techniques for cooling of these such high-end machines. And software optimization is also one field where one can think of working energy efficient algorithms. In fact, this spiking neural networks in AI, they start working only when they cross a threshold limit. So they are quite energy saving algorithms. So a lot of work is going on for energy efficient algorithms. AI driven power management is another area for such huge data centers. And the broader impact will be sustainable exascale computing will have lot of impact on health, energy, astrophysics, and many more fields. And climate modeling for addressing the global warming effects, global initiative in sustainable HPC development. Because I told you the exascale machine takes how much power, so you need to have the sustainable HPC systems for providing that power, the computational power, at less electrical energy. These are the exascale computing market currently, the hardware, software, services, and here where it is used in government, defense, healthcare and biosciences, research and academia, financial services, manufacturing, energy, and others. You see the kind of market it has got, the kind of rise, the percentage rise in the market cap. What are the limitations of CPUs? Now we will see why these newer eras are coming. So general purpose tasks, the CPUs are designed for general purpose tasks. That's why they are bulkier, bigger, but they struggle with AI workloads. Because you all know that AI tasks requires metric multiplications to large size matrix operations and convolutions. And the solution is specialized hardware based on accelerators like GPUs, TPUs, ASICs, LPU, NLU. So many have been launched, the specialized hardware in specific areas. They offer superior performance and at the same time energy efficiency. Performance even you get from the CPU and GPU combined together, but the energy efficiency comes from the accelerators like TPUs, NLU, LPU, and other things. Faster training, and when you need to train the deep learning models, you need a faster training and interference for larger models. All of us know this. And what is required is we need a greater energy efficiency at lower and lower operational costs. Because I told you the operational cost for an exascale machine is very huge, and latency also is to be reduced for real-time applications like self-driving cars, robotics, because even these application areas rely heavily on the computational power provided by the computational resources. And edge AI is providing AI on resource-constrained edge devices. So there is a focus on in edge devices currently, and hardware innovations. These hardware innovations are providing a breakthrough in deep learning for training of the deep learning models, and they are providing helping in manufacturing not at large scale, but to some level edge devices are there, and cloud-based AI services which are powered by GPU and CPU, TPUs are available to a general public also currently by Google. Quantum computing, the next frontier, it utilizes quantum mechanics principles, superposition, entanglement, interference, operates with qubits for exponentially increasing computational power, whereas in traditional CPUs, if you increase some time limitation. So if in traditional CPUs, if you increase the number of bits, the performance increases linearly only, whereas in case of quantum computing, if you increase number of qubits, the performance increases exponentially, although the error is also there. And it is expected that it will solve the problems that are rather difficult for classical computers. And it will revolutionize the industries of pharmaceuticals, finance, material science, cryptography. Though it is in experimental stage only, companies like IBM, and IBM is the frontier in this, and then Google, Intel, they are at experimental stage only, and they are having research teams to reduce the quantum errors and working on reducing the quantum errors. And the next could be pneumomorphic computing, which mimics the brain of a human. So what happens is, how human brain works is, it has got neurons and synapses. So these machines based on pneumomorphic computing will learn and adapt in real time. In contrast to traditional AI algorithms, where you need to train the using deep learning methods, you need to train the model and then use it subsequently. And in pneumomorphic computing, on the fly it is going to learn like human being. And event-driven processing, this will utilize the event-driven processing, as I told you, in spiking neural networks. So it is going to save a lot of energy, and integrated memory and processing avoids data transfer bottlenecks. So memory, logic and data on the same integrated circuit will save the costlier data transfers. And it will save energy for tasks like image recognition or speech recognition. IBM is leader in pneumomorphic computing. True North is architecture which is published by IBM, and it is highly efficient and low power processing, has got very low power, providing high computational power at low energy. Energy means consumption of electrical energy. Analog computing is also at its lab state only, and it leverages physical laws of speed and efficiency, uses continuous signals like voltage, current instead of discrete bits, and it will apply physical laws, Ohm's law and other laws, to solve the computational problem. It will have the basic elements like integrators, summers, or differentiators, and you model the equation of problem to be solved using these integrators or differentiators, and then additional components could be there to solve the problem, and first of all model the problem and then solve it. And it is going to be highly energy efficient for tasks like linear algebra, differential equations. And advantages are that these analog circuits, they perform tasks very quickly. They will perform tasks very quickly, and ideal for energy efficient algorithms. So a lot of work is going on this technology at the labs of leaders like IBM, like Intel. At the end, I would like to say that major players like NVIDIA, Intel, IBM, AMD are investing heavily for extensive use of GPUs and AI workloads at present. And they are incorporating AI acceleration features in their processors, in their architectures, and coming out with AI accelerators in for variety of tasks. But as of now, I would say that people are better to work in broader spectrum of cognitive and social tasks, that too under wide variety of unexpected events and circumstances. There is a publication, full-fledged publication on this comparison also. So this is the crux of that publication, which I have put as a line here. And I will say that convergence of these latest technologies, exascale, AI, quantum, neuromorphic, and analog will make transformative shift in high performance computing paradigm, which is the backbone of all whatever is available to us as a user. And in future, integration of these technologies, technological advancements will drive the next wave of scientific, industrial, and societal progress. Thank you all. National Quantum Mission Government of India has established. And हाँ मैं समझ गया आपका क्वेश्चन.
थोड़ा हिंदी में बताना मुझे. हाँ थोड़ा हिंदी में.
हाँ देखिए आपने पूछा है कि इंडिया की पोजीशन क्वांटम कंप्यूटिंग में क्या है, यही है ना क्वेश्चन.
हाँ कंडीशन प्रोग्रेस
एंड प्रोग्रेस.
यस मैम.
गवर्नमेंट ऑफ इंडिया ने एस्टैब्लिश किया है नेशनल क्वांटम मिशन.
यस मैम.
है ना, और उसमें बहुत सारी एजेंसीज को इन्वॉल्व किया गया है, जो लोग उसमें पूरा अपना एफर्ट्स लगाएंगे टू कम आउट विथ ओन. देखिए क्वांटम कंप्यूटिंग में सबसे इम्पॉर्टेंट है टू डिज़ाइन द आर्किटेक्चर एंड इवन डिज़ाइन द सॉफ्टवेयर एप्लीकेशन. तो इसमें से जिसमें भी हम फ्रंट में आ पाएँ, गवर्नमेंट का ये काम है, मतलब ये इरादा है. तो आपको अगर मैं बताऊं, इंटरनेशनल सिनेरियो में अगर आप मोस्ट साइटेड पेपर्स पता है, जैसे हम पब्लिकेशन करते हैं उनके साइटेशंस होते हैं, तो क्वांटम कंप्यूटिंग में अगर साइटेशन के हिसाब से देखें तो यूएसए फर्स्ट आता है, चाइना थर्ड आता है, इंडिया 20 नंबर पे आता है. लेकिन अगर पेटेंट्स के हिसाब से देखें तो 339 पेटेंट्स हैं इंडियंस के, और हम 9वें नंबर पे आते हैं. तो अभी एक इवॉल्विंग फील्ड है, लेकिन थ्रस्ट मतलब गवर्नमेंट का थ्रस्ट है, मतलब कि एफर्ट लगा रहे हैं, गवर्नमेंट भी लगा रही है कि हम इसमें एक वर्ल्ड के लीडर के रूप में उभरे.
यस मैम.
है ना
मैम एक और क्वेश्चन है मेरा.
हाँ,
ये यूएसए सुपर कंप्यूटर में टॉप पे है, तो उसके कितने कंप्यूटर है टॉप 500 में?
उनके कितने कंप्यूटर
टॉप 500 में?
नहीं पता
मैम कितने हैं उसके पास?
हाँ
कितने कंप्यूटर है टॉप 500 कंप्यूटर उसमें?
टॉप 500 की जो आधे से ज़्यादा लिस्ट है ना,
हाँ,
यूएस की है.
मैम गिनती ऐसे कितने नंबर है ऐसे?
नंबर तो मतलब टॉप 500 के आधे से ज़्यादा, यानी 250 से भी ज़्यादा आप मानिए. और क्या हुआ है कि इतने सालों में उनकी मशीन टॉप कर रही थी, फिर 3 साल तक, 4 साल तक, 2 साल तक फुगाकू ने, जापान की मशीन ने टॉप किया था.
yes,
फिर उसके बाद ये चाइना ने ओवरटेक कर दिया था सुपर कंप्यूटर में यूएसए को.
yes,
चाइना की मशीन्स टॉप कर रही थी बहुत समय तक.
yes,
लेकिन 2022 से फिर जब इन्होंने एक्सास्केल कंप्यूटिंग का लॉन्च कर दिया,
yes,
जो मैंने बताया आपको, फ्रंटियर है या फिर EI कैपिटन, तो अभी वो लोग टॉप पर वापस आ गए.
मैम एक और क्वेश्चन है मेरा, इसे ये भारत के ऊपर पाकिस्तान और चीन से अटैक होते हैं साइबर, उसका क्या व्यवस्था की है भारत ने अभी?
देखिए वो क्वेश्चंस में उसका आंसर पब्लिकली मैं राइट पर्सन नहीं हूँ, लेकिन मुझे पता है वी हैव सुपर कंप्यूटर्स टू प्रोसेस द डेटा. बस मैं इतना बोल पाऊंगी.
मैम और कौन सा क्वेश्चन था मैम? सच बात
हाँ, अगले सेशन में आप सर से पूछ लीजिएगा.
गुड आफ्टरनून मैम. आई हैव अ क्वेश्चन. मैम आई एम सेइंग दैट क्या आपको लगता है कि जो अपने स्मार्टफोन्स के CPUs हैं,
हाँ,
वो PC के CPUs को रिप्लेस कर सकते हैं?
देखिए स्पेशलाइज्ड टास्क के लिए यस, लेकिन आप PC बहुत जनरल पर्पस के लिए यूज़ करते हैं. एट प्रेजेंट ऑल्सो यू कैन रिप्लेस इट, अगर आपका पूरा हार्डवेयर उस तरह का हो. लेकिन आप जो कुछ और काम करते हैं उस पर समटाइम्स इन फ्यूचर आप देखिएगा ज़रूर होगा ऐसा.
यस मैम, जैसे कि अभी देखा जा रहा है, आपने बोला फ्लोटिंग पॉइंट कंप्यूटेशंस, तो वो बहुत हाई स्कोर्स अभी अचीव कर लिए गए हैं क्वालकॉम के द्वारा, ऐसा स्नैपड्रैगन एलाइट प्रोसेसर पे. तो अभी उसको भी सीपीयूज में यूज़ करा जा सकता है क्या?
एक्चुअली देखिए सीपीयूज क्या होते हैं, पावर हंग्री हैं, इसीलिए तो आपके स्मार्टफोन में सीपीयू नहीं यूज़ किया जाता है। अगर आप माइक्रो आर्किटेक्चर लेवल पे देखें तो सीपीयू का जो माइक्रो आर्किटेक्चर होता है उसका इंस्ट्रक्शन सेट बहुत बड़ी होती है, क्योंकि वो डिज़ाइन होता है जनरल पर्पस टास्क के लिए, जबकि स्नैपड्रैगन आर्म प्रोसेसर्स जो होंगे ये रिस्क प्रोसेसर्स हैं, इनके एक लिमिटेड इंस्ट्रक्शन सेट होती है, तो उनका हार्डवेयर भी उस तरह से डिज़ाइन होता है। दैट इज़ वाई दे आर एनर्जी एफिशिएंट, कम एनर्जी लेते हैं और बैटरी पे चल जाते हैं, जबकि जनरल पर्पस टास्क के लिए आपका इंस्ट्रक्शन सेट बहुत बड़ा होना पड़ता है।
ओके,
थैंक यू सो मच।
Thank you, ma'am, for such an instigating speech. Now, I request Professor Angita Hirve, madam, to kindly present the token of gratitude to Professor Alpana Rajan, ma'am. Thank you, ma'am. Next, we have with us Professor R.K. Pateria, sir, who is currently giving his valuable services in Manit, Bhopal. I request sir to kindly come upon the stage with his few insightful words on topic cyber physical system and its security. Thank you, sir.
HDMI option है तो नहीं सर, टाइप सी टू HDMI
टाइप आप एक काम करिए ना, can you give Wi-Fi connection, password of Wi-Fi connection? I want to disconnect. You have to connect this one, my phone.
No, actually we have it.
No, I am already here.
Okay, no problem.
You give power to this and connect this.
पावर कितना है यहाँ पे?
पावर होगा, इसको उसमें कनेक्ट कर।
हो गया कनेक्टेड, वो भी कनेक्ट हो गया सर, पावर आ गया सर उसका।
इसमें आपका वो नहीं आ रहा शायद, इंटरनेट नहीं आया।
नहीं सर, कनेक्टेड है सर डिस्प्ले से, हाँ ये कनेक्टेड है डिस्प्ले से।
आ जाना चाहिए।
लुकिंग फॉर अ डिवाइस।
हाँ,
नो डिवाइस
हाँ
फाउंड।
वो कनेक्ट नहीं, पावर नहीं है उसमें। पावर है।
डिवाइस फाउंड।
वो एक्चुअली पता नहीं क्या प्रॉब्लम है, इसमें पावर आ रही है ना।
हाँ सर, पावर तो आ रही है सर। सर अंदर से कनेक्ट करेंगे इसको डायरेक्ट।
अंदर से कैसे करेंगे? यहाँ इसको आ जाना चाहिए डिस्प्ले में। ये नो डिवाइस फाउंड आ रहा है।
अच्छा ब्रिज है। हाँ
कोई और कन्वर्टर हो आपके पास तो?
मैं बात करूँ,
वो कनेक्शन छोटा वाला दो।
एक मिनट में बोल दिया एक मिनट। मेल पर हो पॉसिबल है?
नहीं, कुछ नहीं करना, सिंपल चलता है वो। हाँ वो नहीं चल रहा है, वो कंटिन्यू। लेकिन यहाँ डिस्प्ले नहीं आ रहा, डिस्प्ले आना चाहिए। डिस्प्ले नहीं आ रहा उसमें। डिस्प्ले आया था ना क्रोमकास्ट, वो नहीं है। मैं आपको मेल कर दूँ। हाँ, पेन ड्राइव मेरे है आपके पास? नहीं, पेन ड्राइव वायरस फ्री। हाँ सर, कैसे स्लाइड होगा?
हाँ वैसा। पेन ड्राइव कर दो। ये प्रेजेंटर तो सामान में नहीं और कुछ सर, अप एंड डाउन फॉरवर्ड। सर गो इट्स रेडी।
So very good afternoon. It has already been delayed by few minutes. Okay, sorry for that. It's working? Okay. So it has already been delayed, I think due to connection problem or some other problem. But I am sorry for that. And another thing, I have been told to cover it within 30 minutes only. So I have cut it down for accordingly. So what I would like to introduce this cyber physical systems first of all. The concept of cyber physical systems, why these systems are important, and why security of these systems are important, and some basic threats which are there in these cyber physical systems. Okay, so since our sorry, next. हो गया? चेंज यहाँ से होगा क्या? नहीं, वो नहीं है। ये शायद इसका रिसीवर कहाँ है? ठीक है, बैटरी साइड कहाँ है? So, and keeping in view the key words which are there in our this conference cycle. So the keywords are which I already told you in my speech, that communication, computation, and information technology. So all these words basically make the cyber physical systems. So cyber physical system means any physical system which is having the capability of connecting with with cyber world. So all those kind of systems are known as cyber physical systems. So you can see here, so these cyber physical systems, these are having physical components as well as these components which are there in cyber world. So you can see network, internet, cloud computing, sensors, smart devices, then human components. You can see that implanted medical devices and smart devices, smart cars, all those are cyber physical systems. So these these cyber physical systems basically affecting and making a great impact on our life. So you can see we are talking about Industry 4.0. So in Industry 4.0, so most of the machines, heavy machines and all those working process and production, all these are controlled by these cyber physical systems. Through the internet, through using cyber world, we are controlling all those systems. So, so we can say these algorithms are making decisions for us every day. So, for example, you can see that smart car is one of the example which we can see that it's a physical system, cyber physical system, or you can see that some wearable devices, for example, smart watches which you are wearing. It's a kind of wearable device which actually collecting your data, collecting your different parameters like body temperature, like your heart rate, and like your cholesterol level, and several other things, several parameters related to your human body, your body, that is being collected by these smart watches. And this may be one example of cyber physical system. So any system which is physical in sense and connected with cyber world, that is cyber physical system. So our generation is actually the witnessing generation, which are means we are the witness of advancement in this particular technology, cyber physical system. Okay. So the important thing is whether the algorithm which is taking decision for us, whether it is fair or not. So security of those softwares which are installed on those systems, that must be fair. So for example, suppose we are traveling in a driverless taxi. So how driverless taxi means runs on the road. So it is behind the scenes several complex algorithms are working, and all those algorithms which are using some AI and machine learning behind that, some inbuilt processors are there in that smart car or taxi, so that is taking decision in the real time. So suppose it's passing through a crowd. Okay, so if a person comes in between the road, so how it will detect that there is some body which is going around, so that it has to take decision immediately that we should change our route, otherwise it will get struck with all those human beings. Okay, or all the passengers passing by from that road. Okay, so suppose we are traveling on the road on that driverless taxi, and you see someone has hacked that system. So what will happen? So he may delete, he may give as input to the raw image false images to that system. As you can see, suppose if the real time picture is showing that some human is going on, And if the false images, those images of those persons which are appearing on that image, that is deleted and that is given to as input to that system. So what will happen? So that system which is embedded into that car, that will get confused and will hit the persons who are before that car. So the important thing is why this algorithm which are working for us, those must be fair. So security of these cyber physical systems are important. So the important things which are in cyber physical systems are feedback control of the physical world. So feedback control means what? Feedback control means what? The cyber physical system takes in, like you may be knowing that reinforcement learning. What happens in that kind of learning? Basically, it learns through the feedback given to that system. Okay, so. So sensors are there. Sensors are again physical devices. Those are connected with that, and through the sensors we are taking input as feedback to the system. And then real-time computation. So real-time computation is another thing which is very important in this cyber physical system. Otherwise, what will happen? If delayed computation is there, then there is no use of all those. For example, I have given you that example of a smart car. If it is going on the road and it is taking the late decision or delayed decision, then there is no sense. It cannot run on the actual road. Okay, so real-time computation is important. Then it's safety critical applications. This is there because you can see that cyber physical systems mostly working for the human being. So safety is very much important for them. So there should not be any kind of hacking or that algorithm should not perform. Means delayed action should not be there and wrong options should not be that delivered by this algorithms which are embedded in that. So we may see this slide is showing the different applications. So the very popular applications you can see that is smart grid. One is smart grid you can see. So smart grid is nothing else. It was earlier power grid, and now when power grid, that is the function of that power grid is to distribute the power which is being generated. Okay, so that power grid when connected to the cyber world means through with the use of internet technology or cyber world. So when it is using that, then we say it's a smart grid. So this may be one of the examples. Then you can say smart transportation. So again, I have given you that example of a smart car. So there may be driverless truck. There may be some vehicles which are controlled by the through the internet. Smart building. So all the functions which are there in building that can be controlled as that can be made as that's cyber physical systems. Okay. So then precision agriculture, defense, pollution, and several examples you can see in this slide. So these are again you can see that applications which I have shown you. So a few points of those applications are there. So you can see real-time monitoring of traffic infrastructure. So traffic signals, cameras, and traffic controls, these can be seen. Vehicle infrastructure coordinated transportation. So ambulances and that transit signal priority. Then vehicle-based transportation, that proximity detection for safety, vehicle health monitoring. These are some of the applications. So industry 4.0, this is a very popular term, or we can say a buzzword nowadays. So in this, the production process in the industry that is being automated. So machines are not controlled by human being only. It's for the precision, precise output, or the for the precise product, it is being controlled by the computers. So these are a few other applications you can see. Then so 5C architecture, this is important in this industry 4.0. So these are connection, conversion, cyber, cognition, and configuration. So so you can see connection. Connection means connection with with the cyber world, with the physical devices which are there implanted or integrated with that cyber physical system. So that must be connected with the cyber world. And then conversion. So raw data into useful information through data processing, filtering, and analysis. This is another thing. Conversion. Then cyber, so cyber you already know. Then cognition means intelligence. So it should be able to take its decisions. Okay. Then configuration. So configuration that implements feedback loop to the self-optimization and self-healing system. So heterogeneity. So these are the challenges. So important thing, we are talking about security of that, and because security is very much important because they are directly affecting the human being. We are directly connected with that. So security is important, and these are the challenges to the security. So first challenge is that heterogeneity. Heterogeneity is very much a very big challenge in cyber physical system, because heterogeneity means what? Heterogeneity means what? Variety of systems are connected in making a cyber physical system. In any cyber physical system is made up of several with variety of different systems. So that is there. Then connectivity, so increased exposure to cyber threats. So earlier, then if we talk about these systems which were there in we must say suppose in industry, the systems, they were not, means at that time we were not afraid of this any kind of security attack before 2000. Okay, because they were standalone system, and those were not connected with the cyber world. Okay, so and these legacy system and resource constant, these are the challenges. Then so actually when I cover this topic, so I take the security in three-dimensional view. So the four major applications of CPS cyber physical systems are these. That ICS, that industrial control system. Another one is that smart grid, medical devices, and smart cars. Okay, so in with reference to these four applications, I normally discuss all those security of cyber physical system with taking into account all these four examples or applications. And if we take all those four applications in one dimension, and in another dimension, if we take that security means if we divide security in four parts, then we can study security in four different divisions: that threats, vulnerabilities, attacks, and control. So in one direction we can take all these four, and in another direction we can take these four examples of CPS system, and in another direction we take that three components. cyber physical and physical. So accordingly, according to different combinations of these, for example, cyber part, ICS application and attacks on that. Or another example maybe like cyber physical, smart grid and threats on that. So likewise various examples, various scenarios may be created how security can be affected. And how we should study that the security on the system. So different scenarios can be created. So I will show you some of the, since this is not possible in this small duration to cover all these things, so I will take few examples. Only the threats part I will cover. Okay. So otherwise vulnerabilities, attacks, controls, all those things are there in this cyber physical system security. So we will see only the threats and few scenarios which are there which can occur in CPS security. So first of all, types of threats. So there may be different threats: cyber threats, physical threats, and cyber physical threats. So these are applicable. This classification is especially for CPS because CPS can be divided into three parts: cyber physical, and this physical. So physical thing, then cyber physical part, and that cyber threats. So then threat actors may be that hackers, insiders, nation state attackers, and all. So now you will see few scenarios. And before that, you can see this attack tree. So what kind of attacks and threats which are possible on this? So in different directions, you can see, if we see the communication side, then there may be different attacks like packet replaying, eavesdropping, packet spoofing, interception, civil attack, selective forwarding, and similarly for acquisition, then for feedback, computing, and sensing. So it's a attack tree which shows that how many variety of attacks may be possible on cyber physical systems. Okay. So this figure is not made by me. I have taken from somewhere. I forget to write source here. I should write it. Okay. So in that figure, as you remember that three-dimensional figure, I have written four kinds of representative applications of cyber physical system. So these are industrial control system, smart grid, medical devices, and smart cars. So I have already introduced a little bit about these. Now, industrial control system, I have already introduced. We can skip these slides. So we will see directly the scenarios. Smart grid, and then medical devices and communication protocols in smart cars. So these are the different applications. Now, security threats. So you'll see. So normally when we see the security threat, traditionally if we see the model, so what we consider, that is three things, that CIA model. So confidentiality, integrity, and availability. These are the main things which we consider. So now, so if we talk about that CPS, so we can divide this security in 5 parameters, that source, target, motive, attack vector, and consequences. So accordingly, a source may be that adversarial, accidental, or environmental. So these may be the sources. Then target may be the specific CPS application. Then motive, what is the motive behind that? Then attack vector, then consequences. What will be the overall consequence by this kind of attack? So these are the threat vectors. And according to these 5s, we'll see. So here you can see in this scenario, all these 5 terms, that source, target, motive, vector, and consequence. So all these are there. Source, target, motive, attack vector, and consequence. So accordingly, different scenarios are created, and so we'll see that source may be like system familiar attacker, and this is this we are considering for industrial control system. So in our three-dimensional view, you may be remembering that four applications are there: ICS, smart grid, and then third and fourth. Do you remember? So first one was ICS. So we are considering ICS. Then we will see for some medical devices. Then we will see for smart grid, and for the fourth one is. Do you remember that? Okay, no problem. So the source may be system familiar attacker. So for example, one particular employee is not employee who is working in a factory is not got promoted. So what he will do? He may perform some kind of attack. So source may be system familiar attacker. So person working in that system only. And then target is ICS application. This is very obvious. IC whatever application or whatever plant that is being connected with cyber world. Then we can say that is ICS application. Okay. Then criminal motive may be criminal gain, and then vector may be exploiting wireless capabilities for remote control. So you may be remembering that vector means attack vector is the method used to carry out the attack. Okay, so different methods may be there. So out of this, we can say that vector, this is exploiting wireless capabilities for remote control, and consequence is operational disruption. Okay, so I will quickly go through the different slides, and then we will discuss few queries. So this is scenario 2 for again for the same as ICS. Then this is scenario 3. This may be politically motivated espionage. So source may be intelligence agency, and then target may be national critical infrastructure, political espionage, and then spreading malware and confidentiality violation of critical data. So maybe like China may want to destroy our system. So this may be the real life example for this scenario. No? So there are different scenarios, but I think I am taking too much time, and I have to complete within time limit. So I am just going through these slides. Okay, so you can see, and since I have already given these slides, so these will be shared with you. So these are different scenarios. So, and after it finally different scenarios are there, but it will take too much time to cover. So these are some of the open research challenges and future direction in this area. So you can note these points and can explore further on the available resources on cyber. These are our Indian government initiatives. It's a 3,600 crore project which government of India has initiated for improving that. This is NMICPS. So National Mission on that initiatives in cyber physical systems. Then this is the overall conclusion. So this is very crucial for critical infrastructure, and continuous research is necessary, and multi-layered security approach is necessary. And this is all about this, because it will take too much time for that, and it's very so thank you very much. So I have quickly that show conference we cannot get the entire knowledge of a particular subject. The point is that means there must be a click in your mind. So that click inspires you to find out deeper details of that particular point. So if you have that approach, then you can have a kind of spark in your mind that can be converted into innovation. So that is the basically aim of any conference. Okay. So not everything we cannot learn in conference, but we can have some idea about the title or topic or something, so that we can explore further. Okay. So cyber physical systems and why these systems, what are those systems, why the security of those systems is important. So this very briefly I told you, and I could not discuss in detail because of the limited time. Okay, but I hope you may have got some points on which you can explore further. Okay. So thank you very much. If you have any questions. Thank you.
Please stay on the stage for 5 more minutes for the token of gratitude.
Yeah, sure.
Thank you, sir. The information that you have imparted about such an advanced topic is indeed very useful for all of us from the research point of view. Now, I request Professor Deepak Shukla, sir, to kindly present a token of gratitude to Professor R.K. Pateria, sir. Thank you, sir.
Cyber physical systems are crucial for modern industries, enabling enhanced efficiency and automation. Now, the third Now, the third keynote speaker for today is Mr. Narendra Chintamu, CEO, Maha AI, Texas, USA. Due to his busy schedule, Sir couldn't make to come today in person, but got ready to share his valuable time with us online. Mr. Chintamu is a growth-focused person who specializes in solution design, business and system analysis, project and change management, digital transformation, information security, IT infrastructure governance, and many more, along with professional certifications in almost all domains. As an enterprise architect with nearly 20 years of global experience, he holds 38 patent publications and grants in United Kingdom, Australia, and India. A member of the editorial committees of international publications and the author of 7 books on research and machine learning. As a candidate for Chief Technology Officer at MIT, Sir has represented papers at numerous international conferences. Aligning IT operations with cutting-edge technologies for maximal revenue impact with minimal resource utilization is his area of expertise. Recognized for accelerating performance, augmenting efficiency, and facilitating long-term business success, he has streamlined IT infrastructures, reduced costs, improved quality services, and bolstered security for a 21 billion company. A multilingual expert with exceptional interpersonal, organizational, and relationship management abilities. Let us connect with him and get drenched with experience and knowledge. Topic for today's discussion is bringing ancient wisdom by connecting with the advanced modern technology.
Launch in the airport, so I know we have been a little delayed. Can I share my screen, please?
Yes, sir, you can share it.
Okay, thank you. So I hope you guys are able to see my screen. Can you see my screen, please?
Not right now, sir.
Okay, let me bring it back.
सर को वो कर दो हाँ स्पॉटलाइट कर
I think it says that I'm sharing the screen.
अब दिखाओ सर को उस पे नरेंद्र सर को yes sir your screen is visible just a minute sir
So can you guys hear me now?
Yes, sir, I hear you.
Unfortunately, I'm not in a suit professional. My
Yes,
apologies for
you.
that.
I think your screen is shared. No, no,
Yeah.
sir, your screen is not shared right now.
Okay, let me try to bring that. Apologies for the delay. Let me see. Yeah, I think someone has to allow me to bring the screen.
Just a minute, sir. I will just take it. No, sir, you are allowed to present your screen.
I'm sharing my screen right now.
Yes, sir. We see your screen, sir.
Thank you so much. Can you guys hear me and see me? I would request someone to confirm which screen I'm sharing right now, so that way I can take the presentation, move forward. Can someone please confirm they can see my screen?
Yes, sir. We see your screen, your PPT. It's good, sir. You can now start, sir.
So, yeah, in the online, I can see Mr. Anurag sir sitting, but not my screen. I think that should be fine, is it?
Yes, sir.
Okay. So I just want to make sure that all the people are listening to me. So great conversation so far. I was listening from last 1.5 hours. Great insight, content, especially the Indian community was kind of so powerful of creating the atomic research and all those stuff. Really excited of sharing my vision and envision both coming together. So my apologies, I'm not able to come to the online because of the lot of tide and travel. I'm in a transit right now. So let's go through. We have right now exactly about 24 minutes. I'll try my best. I'm starting at 1 hour 26 minutes in Indian time. The Maha AI Research Lab is empowering today, also securing tomorrow, blending the ancient wisdom and also the modern science for a sustainable future. The presenter is me. Of course, yes, this is Narendra Chintamo on the 7th of Feb 2024. This is Maha AI. So the introduction about me, Narendra Chintamo, a global recognized innovator, researcher, and also entrepreneur dedicated to transforming the future technology of science with a deep commitment to bringing ancient wisdom with the modern achievements. So when I say the ancient wisdom, so probably I have to give 1 minute at 1 minute 27 1 hour 27 minutes. So I'll take about 30 seconds here. So uh, bringing the ancient wisdom. So when I grew up in a small village, coming from a farmer's background, probably I spent my life so joyful. So I'm so pity the current generation is not having that kind of life. Um, this is possibly good or a bad. I'm not commenting anything right now. It's a recorded camera. I just wanted to talk very sensible. Let's see what's going to happen in the future slides. So Narendra has played a pivotal role in the AI, robotics, IoT, human health research, and sustainable solutions. Founder of Maha AI Research Labs, a pioneering innovative integrating AI robotics and ancient sciences. Let's go back and see where are we now. That's the intention behind it. Recognized by the global governments, institutions, an official partner. The signings are going with right now with the UAE government, the scientific research of Emirates scholars. I'm an official partner for the Florida governments and the USA governments, a leading scientific researcher, world's top most scientist who knows 12,756 subjects in depth of giving the keynote speaking, highest number of innovative patents, who read ancient Vedas, ancient agriculture, ancient way of the religions across the world, and probably M927 innovator, probably 1,000 times better than the Atom. I know people will ask the questions. I can answer in Hindi, English, Telugu, probably 1,300 languages. They can ask the questions right now. I can answer in their own native language. So I know 1,300 languages right now. So the world's leading researcher, innovator, with thousands of publications, every single organization, the topest organization in the world, has Narendra Chintamo's innovation, including NASA, Harvard, astrophysics, and all the security agencies in the world using Narendra Chintamo's patents, technologies, publications, advisor board member, actively contributing to governmentals, defense, because I have my own defense land. That's what I think Florida promised, which is in the process right now in the camera. I don't want to talk anything nonsense here, which is not completed yet. And the research organizations across the worldwide, global education, research leader, leading 10 colleges in India right now. We have 50,000 students and research initiatives and key areas are like health, technology, IoT, sustainables, and robotics. So let's work on what's happening with our plants. Um, Many immigration organizations or the countries were bringing the people from a multiple countries, but I think they lost that um, intelligence, that their intelligence is connected with the plants, connected with the cows, connected with the birds, connected with the nature where they're living in. So we are trying to bring along with the human to the immigration. We are also bringing their culture so that the companies who are bringing the immigrants will be so much intellectual. We had a small survey in America where people was used to drive at 12 hours after coming to United States with the air conditioned, no D vitamin. I think they were suffering to drive even through 2 to 3 hours. I have some verifiable evidence that one of my friend told me that my son was so kind of strong, no antibiotics. Now he is kind of sick every single time because I don't know. I do not have any verifiable evidence, but I could say that I think the probably culture is missing. So let's go a little forward. We are talking about 1 hour 32 minutes in Indian time. We spent 6 hours, 6 minutes so far in talking about what is Maha AI. Let's spend 1 more minute on what is the mission and the vision of Maha AI. My mission, when I say it's not my, it is I, nor the we. So I'll talk about what my I, we in next 17 minutes from now. It's a recorded line. You can track after 17 minutes. So, a mission is to create the future where cutting edge technology and ancient knowledge work together to empower the current generation and secure the future generation through, if it's not Maha AI, someone else's organization, but we are trying our best. We are developing AI driven solutions for health, security, and sustainability while preserving the wisdom of the past for the long term innovation. So, why should we preserve the past? Because, according to the research of Narendra Chintamu and Maha AI team, we understood that before 1983, there was no diabetes that what we have today. There was no kind of autism what we have today. There was no pelvian tube impacted, which is nothing but the uh, apart from the natural birth, we trying to create the artificial birth. Appreciate the scientists. We are going forward, but kindly look at that how many surgical operations that we had before 1983. We have all the records and evidences that we try to kind of help the human, but unfortunately, we are creating more problem to the human just because of messing with the culture. It's not, when I say culture, it's not Indian, it's the entire world. We will talk about that very soon. We are at 34 minutes of 1 hour in Indian time. So the digital twin, nothing but you see what's happening outside the world, or maybe the mission, what is doing outside the world. So what Mahaya says that the combined ancient knowledge with cutting edge technology solve modern challenges. Why should I talk about it here in the slide? It to the today, I think everyone is facing at least a minimum, probably 0.7% of either psychology issues or maybe physiology or mental trauma, which was not happened in before 1980. So what's happened to the scientist people? Unfortunately, you guys are not updating yourself. I have a recorded evidence in the world's toughest organization, or maybe scientist research center. Narendra Chintamu said that, hey, what's happening? Why are we not updating? What is your universal omni factor? Sun rising east, which is absolutely incorrect. In my opinion, maybe you can prove scientifically. The sun is constant, the earth is rolling towards the world. The ancient people of every organization or religion in the world clearly said that you have nine planets on the lunar cycle. But probably some intelligent scientist who thought that he woke up in the morning, he saw sun rising from east and wrote a book. That book, he simply copied it and said that sun rising east, which probably may be correct, may not be correct. I'm not coming to any conclusion right now. Maybe you're right, you may not be right. Let me do some more research on it. The empowering present generation through sustainable research while preserving the ancient practices for the future well-being. Whatever you learned from your father, your grandfather, it's coming from an experience, my dear friends, the brothers. They are not simply saying that you should not take the drug, you will die. So the drug might be impacting with the neurochemical, maybe probably the stress is created by either the society or the parents or maybe the academics. I don't know. I'm not concluding anything. We have to do some research. I need my brothers, the younger brothers than me, have to come forward and do some research. Let's make at least we got spoiled with some our scientists, previous scientists, the previous generation scientists, trying their best to save the future. They're not doing anything wrong to us. But at least let's make sure that whether they're doing right or not, let's have the UAE Scientific Research Center help us, putting a investment or maybe at least supporting us. I have my own Florida government. I'm coming from the an official note from the Florida Economic Forum supporting me. No contracts are signed so far, but at least they're signing. The signs are going to be a positive way. I myself coming from the Southeast, a G20 WBFA official representative for America in terms of the representing their innovations, or maybe the probably not only me. There are multiple people, but I'm the one of them, and thousands of people across the world trying to save the future generation. I'm also US scientific scholar. United States blessed me with a scientific researcher, E16 green card, outstanding scientist in the world, collaborating with 10 colleges in India right now with 50,000 plus students, help my scientist community, RR Tech. I really appreciate, ma'am. You have a outstanding knowledge in the atom research, and I really appreciate that you really spoke about the sensitivity about the atom research. I don't want to call in an open forum that our scientists are in the risk. I know some media channels are talking about 684 the scientific people got killed so far. I'm not talking anything on my own knowledge. I can send the web evidences for that. Homi Jahangir Baba, who is a Baba atomic researcher, named by him. Lal Bahadur Shastri on 11/11/1996, probably killed by a accident from the aircraft. And on 13th day, very after 1996, 11/11, there was a couple of people were killed. I don't want to even say I know the evidence because it is just web. I don't know whether someone put for the good or bad. I'm not talking about it. 08/06 2009, the Qaeda Atomic Center, Lokanathan Mahaling, was killed. That's what web says, who is also atomic researcher guy. And from the nuclear scientist, Ravi Mogle, in a Qaeda academic center, who is also killed. In 2010, Ayer from the engineering, also killed. And in 2012, someone from Uma, she's also killed, unfortunately. In 2013 of October, there was a blast happened, and in 34, the KK Joshi, Abhishek, also killed. So I'm not concluding anything in the open forum. I'm telling you very clearly, this is all web, whether true or not. I know the Indian intelligence are taking care of our scientists. Maybe there's a propaganda, but that should not be impact on my future generation scientists, who's very intellectual in my India. Right now, entire world is looking at the scientists. Maybe that's coming from a culture, that's coming from a some propagandas. Let's not go into what happened in the past. Now we have more intellectual intelligence in the world. If you guys coming far from the colleges, we can put you in the research, and the modern scientists like our RR Tech and ISRO, NASA, UAE scientific research, trying their best to save the future generation. We don't want to go with what happened in the past. At least we can go with the advocates and the future generations. Let's see, hey, I wanted to help the future generations. I may not build Tesla, I may not build Google, I may not build Microsoft, I may not build EA Scientific Research Center, not ISRO, at least I'll contribute a 0.001% of my education that I tried, studied my engineering. Let me at least try to create a VSLI or maybe VLSI, uh, the manufacturing chips growing from India. So in the future generations, they will thrive. We can also take you to China. We can also take you to America. We can also take you to any place in the world if you want to learn, interested. So that's me, Narendra Chintamu. Will take any permissions in the world. I'll take you, securely take you to any country, take it back because I'm talking in a video evidence because I have my own MOUs are going on. We can work with your parents if they are very scary about the scientist. It's not the true, in my opinion. Maybe true in the past generation, but the intelligence team is very strong. As previous speakers spoke about, we have a highest level cyber security right now. So guys, either you wanted to work for a 50,000 salary or 50 years of name. That's up to you. So Maha AI, let's talk about what we do. The virtual device may talk about, see about your intelligence and take me into the Maha AI International Research Center in the Karimnagar, Andhra Pradesh, um, Telangana, and South India, India, and the world. So there is no religion, space, or border. If you want to save your intelligence, just utilize to secure at least your kid who is born in the future. Even today, if someone asks me, I'm just working for my kid, not for the any generation. I'm a selfish guy. If you want to think, right now we are at 1 hour 44 minutes in Indian time. So let me conclude the conclusion. What I'm going to do. The plants were actually have more intelligence than human. Many scientists have discovered that plants can create the food that you need to eat. They are taking your carbon dioxide. They are creating the oxygen. Also the fruits that if we eat, it may not be die. So let's use our advanced technologies for the robotics, IoT, human health, security. Also, let's bring how my plants are reacting on a full moon day, which is on the Purnami. Yeah. So maybe the entire ocean is popping up to the up, and many research in the modern people says that the flowers are flowering so good on the Purnami, which is the full moon day. Let's see, do some research. I'm not concluding anything. Whatever people say, they may say just because they know they read some books, but our colleges should work on a real time. Let's see if they are really influenced by moon. I'm not concluding right now. Let's do some research. So, what is Maha AI focus areas? Let's do some health, human health well-being, robotics, human health tracking. I know the previous speaker spoke about every government in the world trying to save the future. It is our responsibility, being an younger generation. Let's try to help them in the research. Maybe we may not be successful, maybe be successful. Let's take them guidance, they're senior people. Let's try our best while we are studying in the colleges. Let's go very practical. Let's go to China, understand how they are doing the manufacturing. Let's go to Japan, see how they are going to do the robotics. Let's go to Australia or New Zealand. Let's see how they are doing the innovative agriculture. Let's go to Denmark, how they are going to do the innovative dairy. Let's go to America, find out how we are doing the intellectual property securing. So at the end of the day, you are going to make a lot of friends across the world. So no, if you have a friend in the other country, you want to naturally save them, maybe Russia, maybe Israel, maybe any country in the world. Pakistan, Afghanistan, I'm not talking about any religion or region or anything. Let's make friends in the other countries. So naturally you will become friends across the world. So probably there will not be any discussion about uh, the wars in the future. Let's save ourselves and the future generation. At least your kid should go to a college with multi-differential people with their culture, appreciate their culture, and do your own culture because that is in your genes. Your genes does have the seventh generation of memory. Let's not spoil them. Let's not go to the place where you do not have the genes encouragement. So that's what I think we are doing. The pharmaceutical research in 1983, they do not have they have a habit of taking a raw tobacco. No cancer detected, maybe detected with a different reason, but now more cancer because of the chemicals. The scientists wanted to feel human. I'm not talking about any scientist was doing wrong. I'm saying that scientists have their own life, spending to kind of take the easy. Uh, so probably I'm not talking about anything good or bad here. Let's try to help them as a student. Let's try to help our scientist community of how can we save the future, avoid anything that impacting the human health or maybe technology. So let's kind of give some realistic, evidential based, uh, legally accepted analysis to them so that they will also have a lot of help from you guys, and you will also accelerate your research skills. We are here to help you. So like the way I grow, I think I try to help you. It may work for you, it may not work for you, but let's try to do some kind of investigation on it. So the partnerships and collaborations right now, I could convince the UAE governments and the scientific research centers, the MOE is to build research labs in the projects, and the support from the Florida governments is already established, including the satellites and the infrastructure. US investments in the IP, in the advanced research opportunities, because US is the one who take care of their scientists. Uh, so probably I may get some grants, may not get some grants. So in India, I've been in the research of 47 days. So we could convince 10 colleges in the South India. Mr. Anurag Sharma from the North India is working with many colleges to bring the engineering, pharma, the advanced robotics, and also the many other aspects surrounded by the technologies is working. Let's try our best, inject our people, the students, and let's talk about their stress levels, psychology, atomic stress. Let's see if they can help us. If not, I think we will see. We will work with some psychologists and also the robotics people, also the ancient people. Right now, we are at 1 hour 50 minutes. Let me go forward a little fast from now here. So no images from now. It's just image. I don't want you to spend so much time of understanding images right now. The key collaborations, the Jyotish Madi College, Mr. Anurag was so intelligent guy to convert them to Maha AI partnership, which the discussion going. Wageshwari College for Pharmacy Research, Aditya College in Kakinada, who is autonomous college. We have not signed the MOU yet, but I think they are probably trying to give a 200 acres of huge labs, a partially maybe 1 acre of land to Maha AI. I'm recognized by NASA, Harvard, also astrophysics. So I told them how the ancient people, let us say a simple topic about the, let's talk about the Pushpaka Vimana. So some scripts in the ancient world says that a wood can fly if you put some kind of chemical in the ground that will go up because of the light weight and hard weight that can go up. If you put one guy, it will naturally expand. That is called Pushpaka Vimana. With the Afghanistan, combing was found by the American people. So the Pushpaka Vimana in the ancient scripts, I don't know whether that is true or not, but scientifically that is right. The air can kind of take the light weight and hard weight, especially with oxygen, carbon dioxide. We are doing some research right now. I don't want to conclude right now. So astrophysics also identified that there are a lot of easiest ways that we can measure the sun, his health. Someone already told that coronal health of 2025 in the sun, which really gets impacted million years ago. So probably they are the best scientists than us. That's the reason I think we do not have the chemical impact during before 1991 or maybe 6066. I'm not concluding that my research is going to be a super duper human saving. Let's try along with the colleges ending points. So the ancient wisdom always says that millions of plants were treating the people without having any modern medication. There is a verifiable evidence that many modern chemicals were also used by the ancient plants. When I say ancient, it's not Hindu, it's not Sanatan, it's not India, it's everywhere in the world. Egypt, Persians, many countries, Greece, many countries in the world use this kind of technology. So it's our responsibility of not losing the most precious knowledge that they created for us. We will try, we can bring at least the future generations which is going to be happy. If not, that's fine. We tried our best by securing our own family, bread and butter. So we should empower the current generations. So I'm trying best for the 50,000 students. Also, I'm trying to put a international research center and a private organization which is Maha AI collaborating with the governments of UAE. Right now, Australia is helping. Maybe probably UK may also help because I have a lot of patents in there. And America, which is 99.99% confirmed because we have a lot of discussions so far. NASA, Space Center, ISRO, UAE, Australia, Scientific Research Center of Emirates. They're so nice people, putting billions of investment save the future lives. So we will try to train the robotics with the ancient knowledge, the technology, what they have. At least let's try to see if the chemicals are creating a lot of jealousy. The previous generation may not does not have. I don't have any proof, but at least in the research that we have from the people, they do not have this much jealousy. The governments and international research centers are now coming forward, focused on the future projects along with the government projects that we are doing. And let's secure the future generations. At least we already been suffered since 1983. People who born in 1980, they had a very good childhood life, and now people are saying that we are missing. So let's not make that happen to our future generations. Let's bring all the fruits and vegetables, not only with us, with the plants, nature, creature. Let them enjoy the foods of at least what we ate in our childhood, maybe with a natural way, without any chemical, because the chemicals are impacting the human. At least the which is a verifiable evidence that the girls are very hugely impacted with the chemicals, organ systems, and the pelvian tubes. They are getting the maturity at the age of 6 and 7 on average. I don't have any proof. According to the ancient methods, it will take only 12 years, which is a cycle of lunar cycle. They'll probably get a very good eggs, which is the first generation of the Vasanta Panchami, which is the ancient day calling. In the March, you will have a spring in the eastern countries. So comparing with the March and March fruits and the December fruits is always kind of probably I may not be true right now, but probably the March fruits, in my opinions, are very stronger than December fruits. So let's create the March fruits for the future generation, not the December fruits. Let's not go too fast. I know you wanted to influence the food to make more faster than the nature decided. If we do not have a patience in the today's world, I understand that you are not able to even watch a 30 seconds WhatsApp status. In the human day, olden days, they used to sit entire night to listen the scripts and make themselves powerful. Maybe that is the food because you are wanted to have a faster food. They are influencing you. I do not have any difference right now, but let's work on it. So the highlights of the innovations. Let's see. I'm at 1 hour 56 minutes. I'll try to conclude at 2 hours 7 minutes from now, which is almost 13 minutes. So highest number of global patents and recent publications where Narendra Chintama had with probably couple million publications in across the boards and the research centers, also the uh, editorial boards, and also the top research centers, keynote speaking. So probably I was spending some time. I want everyone from the future generations. Let's work together at least. We can do the same research. So integration of defense, security applications through advanced research. Let's try our Indian intellectual team and also the world intellectual team working their best. Let's try to help them. Like a deep sleep, they are the very young blood. Use the existing technology of LLM, which was there from 2015, as our previous speaker said. They used the same technology and created the advanced technology with the less computing system, with the gel technology. And the gel technology is not new, which was there in the ancient world. Probably we have to do more research. And I'm working with the Kanchi Kamakoti, Shringeri, and other couple of ancient running generations and organizations, asking them to convert their script into my own language, which I created, the best language, where I could sense that the language was created by the dynasty or people of religion to secure their IP. So I created my own language in the robotics with most advanced technology. I can bring a 5,000 words into just one word. So let me prove that to the governments and get the approval and work with these people like Egypt, like Mexico, like UAE. So they have their own languages. So let's create one common language for the world in the robotics. Let's see if that works. If not, I think we are just losing a couple of our years. And you still get your internship. You still get your job in the future organizations. If you get so much succeeded, I think you can start your own startup organizations. If someone's stealing my IP, I'm the so much happiest guy because you're going to save the future life. So I'm not worried about my IP. If you can grow the good food to the world, I'm the most happiest guy because the future generations are going to be happy. That's what all my IPs. Many IPs are at the public. A few IPs are not public because we have some corrupted system across the world. I'm not blaming anyone. We put some intelligence in the IP, so they sold it to some companies. I'm happy that they're helping to the world. But we will talk to the intelligence team. How can we secure? So the impacts and benefits that maybe you will get it as a student. Probably you will get global research and development network, which might help you in the future, may not help in the future. I'm not concluding. Empowering of youth and access to advanced research and technology because the governments are involved. Solutions for the chronic health conditions with a mix of ancient knowledge and the modern techniques. I'm not blaming the modern science people because they are also trying to help the next generations. The 38 million people are going to die with hunger. So let's make some deserts into beautiful, beautiful, beautiful agriculture and some amusement parks. Let them empower while we are also getting some money for our self-sustainable. Strong partnership with reading research centers. I'm working with a lot of governments. India is the one, is the last in my space because naturally people will think that another guy is coming from some innovation. We wanted to review and all those stuff because of a lot of, maybe I'm not blaming anyone. I'm just trying to say the process that in the 74 days of research, I could not even meet a local police people, unfortunately, because of the rules of the strict that our Indian intelligence is making. Probably which is good for the future generation and current generations, but not for me. I'm not blaming anyone. They're helping me in many ways, for sure. With the governments and all those people, we are putting an international research center with the help of the local governments, local intelligence, Indian intelligence. We're inviting all you guys, anyone interested, to meet 81 countries, presidents or the governors people to UAE on 19th, 20, 21st of February. Either we can sponsor you or you can sponsor from your college. We are open for the both the ways. Mr. Anurag Sharma can take all the indoor or maybe any people in the world to the conference. Let's discuss how can we secure the better future. I'm inviting the US governments, probably Indian governments. I've not reached out to them yet. And the UAE governments with 11 prime ministers UAE Scientific Research. I have an official email from them that I can bring the people. So I'm talking on a recorded video, on the recorded line. I'm okay to release the IP because that's the intention. We wanted to save the future. So the conference name is Citizen Tolerance. Let's talk about in that in future slides. UAE, MOU, and Florida government partnership we have already initiated. We have completed the advanced labs and the installations in the mini colleges and especially the place where I'm living in. We are launching the major projects with participating in the colleges in 2027 across the world. We have to put our people across the world. Let's have the culture mix up. Let's make our future generation friendship with every single country so that we will avoid the wars because there is no intention or maybe nothing gaining of killing people. They are also humans. Let's at least try our best by connecting the people. No boundaries, nothing. If there is something wrong with that people, we can tell openly. This is going to be harm to your future generations. Let's make sure that we are good in 2028 and beyond. A full research capacity across the world. Every single future generation is going to have a good friend in every single country in the world. That's the mission. So I'm calling for the global partners. You can take the screenshot or maybe you can reach out to me directly. Right now, my America phone is not working due to some issues on my phone, but India phone, especially my website, and also Mr. Anurag Sharma, who is a gentleman, was helping me from Indore from last 4 years. Indore has a lot of PhD guys than anyone else in the states, at least after Tamil Nadu and Rameshwaram. So you guys are the second place. I want you guys to come forward, the colleges, the governments, please help us to save the future. If there is anything that we can discuss in a recorded camera, so don't disclose anything to outside. If you feel anything the speaking is wrong, so my intention is to save the world. If any misspoken, my apologies. But let's together we can build the future that blends the best of the past and the innovation of tomorrow to create a secure, sustainable world for the future generation. Let's give the beautiful life that we had from our parents to the future generations, not killing them. Even a D vitamin we are not able to supply just because of the early morning schools and the stress, creating a lot of drugs because of the a lot of melatonin impact on the human mind is creating a lot of drug addiction. So let's make sure that the future generations are not so stressed because of the parental ambitions. If the parents want to have IAS, let's not make sure that the kid should be IAS just because of father dreams. Rather, let's focus him on what he's really interested. So I could conclude my conversation within 2 minutes before. Fortunately, I could cover everything in that slide. So I'll give like 2 minutes. People can talk in any language. I can answer right now. Thank you so much. This is a wonderful opportunity. Kindly accept any misspoken in this meeting just because of my intention of research should not impact on your personal emotions. Thank you so much.
Thank you very much, sir, for your such a great information about Maha AI, which is the definitely the future technology, and you are working on that future technology, and definitely the last slide I am very thankful for to show that 25 you going to be work and 26 you going to be develop the labs and all those things. So thank you, sir. We are extremely obliged to have you such an imperative conversation with you, with a heavy heart and a note to meet again in the future, such collaborations. Thank you very much, sir. And we definitely connect you for the next meeting or some, we will try to be, ask you to come here in Indore to meet us.
So I'm 24/7 available for the entire world.
Okay. Thank you very much,
My
sir.
life
Thank
is
you, sir.
going on the air and the ground. So if you want to come in person, if you want to be part of the UAE where I can meet you with the G20, WBFA, and also the scientific research organizations. If you think that Indore can be helpful with the colleges, I'm happy to make the collaboration with you. Thank you so much for your wonderful opportunity. Really appreciate. The
Thank you.
first conference with your colleges is so successful in my opinion. Congratulations and all the best.
Thank you.
Thank you all students for listening to me patiently.
Thank you. Thank you very much, sir. Okay, sir, you can take a leave, sir. No problem, sir.
Thank you all. Appreciate it.